I am David, your developer on duty, and in this video we will talk about object variants in Nim. An object variant is a great way if you want to define a type which can have different properties dependent on the kind of the object. So let me introduce an example. I want to create a type which is called shape. And that shape shall be an object, in this case a variant object. And we want to define the property color as a type string. And now, dependent on the kind of this shape, it has different properties. A circle has a radius, a square has a length, and so on. So in order to model this, we first need to introduce an enum of all those shape kinds, and then we can define our variants. So let's write shape kind, which is an enum, and it can be either a circle or a square. And now we can use it in our shape object variant. So we introduce the discriminator field called kind, case kind, which is of type shape kind. And if it's of kind circle, then we want to have a radius of type float. And if it's of kind square, we want to have a length also of type float. The construction of such objects is very straightforward. So let's just assume we want to create a red circle. Let red circle equals to shape. We say the color shall be red. The kind shall be circle. And the radius shall be 9. And now for our blue square, we just write color blue, kind square, and length, let's say 10. We can put it, for example, in a sequence, my shapes, sequence of red circle and blue square. And we can echo it. So let's see what comes out. And you can see we have here a sequence of one variant with color red, kind circle, radius 9, and the rest is color blue, kind square, and length 10. It's also very straightforward to create procedures or functions which act on these types. So in our case, let's define a function called calc area, which takes a shape of type shape and provides a float. Now, dependent on the type of this shape, the calculation works in a different way. So we write case shape.kind, and if it's of kind circle, the result will be pi times shape.radius times shape.radius. And in order to use pi, we need to import math. And if it's of type square, we know that the result will be shape.length times shape.length. So let's try it. Echo red circle calc area, and the same thing with blue square. And you can see we get roughly 254 and 100. There is one limitation with object variants. You cannot easily compare them without writing additional logic. So let's just imagine you want to compare red circle with blue square. Now if you run it, you will see that you get this error message. Parallel fields iterator does not work for case objects. So this is because the equal operator internally uses a function which is not implemented for object variants. So to overcome this problem, we can define our own function. So we define this double equal function where we provide two shapes, shape 1 and shape 2 of type shape, and it will return a bool. Now if shape1.kind is equal to shape2.kind or shape1.color unequal to shape2.color, then we can return false. because we know it's not the same object. Otherwise, we have to look at the case. So case shape1.kind, if it's of circle, we just write result equals to shape1.radius equals to shape2.radius. And if it's of type square, we just do the same with length. Now let's see if it works. And you can see we get false. If I compare both, we get true. It's a shame that you have to implement this comparison operator for object variants yourself. That's why I created an RFC on the GitHub repository of nim-lang to make fields and field pairs also work for case objects, aka object variants. So I hope this proposal gets accepted at some point, then we don't have to write this code ourselves anymore. Let's see object variants in action, and for this I use my side project called Nary, which I introduced in my last video. So Nary is a nice way to create queries. So for example, you can just write let res equals to nary, then select my DB table, and if you call the toSQL function, you will get the SQL statement select star from my DB table. It supports quite a lot of features. For example, you can provide some columns, then you have the columns in your SQL statement. You can say select dist my DB table, which produces a distinct. You can have aliases for columns. You can have also order by statements. You can have function calls in your select columns, for in this case average of column 3. You can have also nested function calls, like here call these column 3 with average column 4, and so on and so forth. You can have some where clauses and even nested where clauses with brackets, and you can have also function calls in your where clause, and the where clauses can also be separated by an or, and you can see that the correct SQL statement will drop out in the end. And in order to achieve this, the usage of object variants was extremely helpful. Let's just look at this function logic here. So when I scan this, let's say query language, then I see if there are some columns, and the column can either be a plain column, an identifier, or some function call. So this is a very nice use case of an object variant. And by the way, the whole output of this query language is an abstract syntax tree, and this abstract syntax tree is also represented using object variants through the nim language itself. Now let's briefly look at the implementation of the data structure which I use internally to represent the query. So there's one top level object called nary. It has a field reference, which is of type reference, and you can think of a table name. And then you can see that it's an object variant. It has a kind property, and this kind property can be nk select, so for select statements, where you can have columns, order by, where, group by, having, and this distinct indicator. So let's look at reference. Reference is an object. It can have an alias and a prefix of type string, and reference itself is an object variant. It has a kind discriminator, which can be ID to identify some plain columns or some table, and it can be a function which has a function name and some arguments which are themselves of type reference. And the implementation is also very straightforward. So for example, the order by clause has a reference to some field and some order, and the order is an enum which can be ascending or descending. The where clause is again an object variant with a discriminator kind, and it can be of type unary, where you only have some value. It can also be of type binary, where you have a left-hand side, a right-hand side, and some operator. And you can also see that I implemented the equal operator for my references in this case to be able to have some comparisons in my unit tests. The rest of the implementation is relatively simple, so I create my macro which takes this abstract syntax tree as an input, and then I convert it to the data structure I've just shown you. And once I have this data structure, I created a function called toSQL, which takes the data structure and produces a SQL statement. I hope I could show you that object variants are very useful when you define your own data structures. You also need to know them if you use data structures which were written by somebody else. I hope you enjoyed this video. Thank you very much for watching and stay tuned.